Hi everyone, this is Inferential Statistics for Researchers, Lecture 1. In this lecture, I'll be discussing uh, the meaning of statistics, that is, what is statistics, and also branches of statistics. So to start with, what is statistics? Statistics deals with three things. Statistics deals with three things. What are those things? Collection of data. Two, analysis of data. And lastly, that is presentation. Presentation of data. In other words, statistics deals with data collection, data analysis, and presentation of data. So these are the components of statistics. Any activities that involve data collection, analysis of data, that's data analysis or presentation of data, that activity comes under statistics. So that tells you that the starting point of statistics is data collection. We need to gather data, we need to gather information about subjects that we want to analyze their information or that we are trying to understand. So after gathering the information, so we can then subject this information, that's this data, to analysis using certain statistical tools, which we'll be discussing later. So we can also communicate the results to the end users by presenting the result of our analysis or by presenting the data we've gathered in a more meaningful way. That is what statistics is all about. Now, now, what are the branches of statistics? What are the branches of statistics? There are two branches of statistics. We have two branches of statistics. So the first one is what we call descriptive statistics. Descriptive statistics. Then the second one is what we call inferential statistics. So what do you mean by descriptive statistics? You recall when I was defining statistics, I said statistics involves three things: data collection, data analysis, and data presentation. So descriptive statistics has to do with description of data using certain statistical tools, such as what we call measures of central tendency. So we can also use what we call measures of spread, of what we call measure of variation. In the statistics, we also use tools such as charts to describe data. And we can also use what we call a table. We use tables to describe data. So in other words, in the statistics, what we do is that we describe and summarize a large volume of data into more meaningful way. So we can use measure of central tendency, that is certain numerical values, to summarize our data. We can also use measure of spread, certain numerical values to summarize our data. We can also present our data in form of charts or in form of table. So all these come under descriptive statistics. Now, what are the measures of this central tendency? Measure of central tendencies we are talking about three main measures. So we have what we call mean, or what we call the arithmetic mean. Arithmetic mean. So we have mode, and lastly, so we have median. All these are called measures of central tendency. So they come under descriptive statistics. We can also use measures of variation. Measures of variation. Measure of variations, or what we call measure of spread. So the popular ones are variance and two, standard deviation. Deviation. These are the two popular ones. So we can use different charts, such as bar charts. So we can use pie charts. So we can use box plots depending on what we are doing. We can use line graph. So there are so many charts we can use to present our data in a more meaningful way. So we also have table. We can actually present our table, and we can also present our data in a table in order to make it uh, more understandable by the end users. So that is about descriptive statistics. So the second branch of statistics is what we call inferential statistics. This inferential statistics is different from descriptive statistics in the sense that in different statistics, what we do is that we try to draw conclusions about the population based on sample information we have. For example, let's say we have in a class of 20 students. We have 20 students in a class. Let me get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let this represent, each of these represents a student in a class. So this is the population. Now, let's assume that I cannot have access to all these students in this class. I can just take a sample, like let's say for instance, I take a sample of just 10 students out of these 20 students. Now, just let's say I just pick any 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the population and this is the sample. So based on this sample that I've selected from this population, I can actually draw conclusion about this population. For example, let's say these students wrote an exam and I have their scores. I have the scores of some of them. Okay. Now, but I don't have access to all of them. Let's assume that I want to know the average score of this, but I don't have access to all of them. So I can just take example of just 10 students out of these 20 students. So I can gather their scores and try to find the average and use some statistical tests to test whether the average here can actually represent the population average. whether the average years and actual, for example, let's say there's a proposition that the average score of this student is, let's say, is 65% in a class. I may want to check whether that proposition is correct by taking a sample of just 10 students and find the average and use certain cycle tests to check whether this proposition is correct based on the information I have in the sample.